Have you heard about it? TradingView can also place live trading orders in this way. Hello everyone, in this video, we are going to explain how to automate live order trading using some of TradingView's scripts. In our previous strategy design, we also shared a plan to use TradingView for live trading, but it's not very flexible because it only fixes the trading signal in the webhook request of TradingView. If we use some backtesting strategies or indicators that can trigger signals on TradingView for trading, the trading signals it sends cannot be notified to other platforms, such as FMZ API interface, which cannot notify the interface to place real-time orders. Therefore, in this lesson, we will use another method to dock the TradingView signal. And here is a document. Here is a detailed document. You can use it as a reference. Traders who frequently use TradingView know that TradingView can have multiple message push methods, such as sending emails or using webhook URLs. We also made a document public before. Here. So today, we will implement it using a new method. For this scenario and principle, beginners who are not familiar with the FMZ Quant trading platform or TradingView may be confused, but it doesn't matter. Let's first explain this requirement scenario and principle clearly. Let's first talk about the requirement scenario. Simply put, we have many indicator strategies or codes that can be used on TradingView. For example, we can load some indicators. Of course, some built-in indicator scripts and other publicly available indicator scripts from traders, which have a lot of resources. In addition to indicators, there are also some publicly available strategic resources that can be used and learned. So how do we use these resources for live trading? We can use the live trading function of the FMZ Quant trading platform to conduct live trading. Although the FMZ Quant trading platform can run the plain language script of TradingView directly, some traders may have more data based on TradingView because the data on TradingView comes from the data center and is not obtained in real time. This data, accumulated keyline length, etc., may have more selectivity. Based on the above considerations, they still hope to run the plain language script on TradingView and have it trigger signals for trading. So the script running on TradingView cannot directly conduct actual trading. Therefore, if we want to run plain language scripts on TradingView and conduct live trading, we can only rely on other platforms. FMZ platform, which can provide a better choice. Our plan for this issue is to use the FMZ Quant trading platform to conduct a live trading plan. Next, let's talk about the specific implementation details of this plan. Let's take a look at the principle. First, we run a plain language script on the TradingView website. When this plain language script sends a trading signal, such as a script display, open long, open short, or close position, it will automatically send a webhook request when the signal is triggered. The URL of this request is set by ourselves and can be set to request a certain interface. Since our solution uses the FMZ Quant trading platform, we can set the request to request an extended API interface to FMZ Quant trading platform. The extended API interface of the FMZ Quant trading platform will send an instruction to the deployed Docker. Of course, the FMZ Quant trading platform is a distributed system, which means that the live trading program we run on this platform runs on specific devices and can be deployed on our own servers, computers, etc. As long as the network and power supply of our computer server remain stable. At this point, the website of the FMZ Quant trading platform will send an interactive instruction to the trading program on our device, and the trading program will receive the instruction and place an order to the exchange. Simply put, it is such an architecture. The strategy we design in this course can also be backtested. On the robot of FMZ Quant trading platform, there is also an interaction button that can be used to simulate accessing the extended API. That is simulating TradingView to access the extended API interface of the FMZ Quant trading platform website, and then sending an interaction command to itself. I will give a demonstration and a detailed explanation later. The entire plan involves 4 subjects. In simple terms, the TradingView website, the FMZ platform, the robot program on the Docker software, that is, the live trading program, and the exchange. And when sending signals, access the extended API interface of the FMZ Quant trading platform website. The FMZ Quant trading platform can send interactive instructions on the live trading page or send instructions to the management end of the live trading program through the extended API interface. The live trading program running on the Docker. The trading program is a strategy we are going to explain in this session, which can receive the interactive signal from the FMZ Quant trading platform to perform specific trading operations. Of course, this signal is also transmitted from the TradingView. It is transmitted to the calling interface. Then it calls the extended API of the FMZ Quant trading platform to send instructions, and then requires the trading program to place an order with the exchange. Finally, there is the exchange we need to configure, which is configured with API key on the FMZ Quant trading platform, so that our robot can place orders. If we want to do such a solution, we need to prepare these four subjects. A TradingView account at least at the pro level, deploying a Docker on the FMZ platform, the exchange API key for placing orders, and the TradingView signal execution strategy, which is the content we will explain in this article. After meeting the above 4 conditions, we can implement the solution. Before that, let's first explain the signal execution strategy of TradingView. How do we implement such a strategy? Let's start with a simple concept. The previous version of TradingView signal execution strategy was not very flexible because we wrote the trading instructions in the URL requests sent by TradingView, which means it cannot pass signals based on the real-time signal variables in the plain language strategy running on TradingView. For example, if we create an alert, it is fixed when it sends a signal. If the alert is triggered for opening long positions, it is only responsible for opening long positions. If the alert is triggered for opening short positions, it is only responsible for opening short positions. So this solution cannot be applied to a certain plain language script strategy that we have written to automatically perform open long or short operations. This kind of design is inflexible. In this issue, we'll change the way in which the signal execution strategy of TradingView can receive the content of the body. In the webhook URL request sent by TradingView. In other words, we have configured alert information on TradingView. We can see that in this alert, we have written a clause with a placeholder, which means that when this signal is sent, it will send such a message, but the clause in this information will be replaced by the closing price at that time, which means that this value is a variable, not fixed. So it's very flexible. In this way, this strategy can receive information and place orders, as well as various changes in information, which is our different design from the old version. After we wrote such a message on TradingView, when we call the extended API of the FMZ Quant trading platform website, we will receive a message containing the closing price. So how do we write this message on the TradingView? We know that we no longer write this message in the previous URL address. We write this message in the message box. We also need to understand what the extended API on FMZ Quant Trading Platform website specifically refers to. It refers to a series of functions of the FMZ Quant Trading Platform that can be operated through an interface. For example, by extending the API, the opening or stopping of a live trading can be automatically controlled. That is, the opening or stopping an automated trading program. We can send an instruction to a specific live trading through the extended API interface of the FMZ Quant Trading Platform website. The main extended API we use in the FMZ Quant Trading Platform solution is the command robot interface. How can this interface be called? Let's take a look at the following call prototype. For example, we have a network request like this. When we configure the FMZ Quant Trading Platform's API key, that is access key and secret key. In the query parameter, when we send this request, It will access the command robot interface, which will send a command to the live trading with a specified ID. And in the request, it will send a character message of OK 12345 to the live trading with ID 1865115. In the URL, the access key and secret key we set can be created on the FMZ Quant trading platform. We log into the FMZ Quant trading platform. In the account column, we can create an access key and a secret key. We click Create New API Key and click OK. We can see the access key and the secret key are here. These two keys need to be filled in separately in the location of the access key and the secret key extended API interfaces on the FMZ Quant Trading Platform website. The above is a way to call the extended API interface command robot. We have previously written this method fixed in the request, and we can see that the message OK 12345 is fixed, and this string cannot be overridable. It has already been written fixed in the URL of the command robot request. The solution for this lesson is to use another way to pass parameters, which means that we need to have the extended API interface that accesses command robot pass a message to the live trading with ID 130350. But the message pass is not in the requested URL, but in the requested body. Therefore, in the second parameter of command robot, we only need to write an empty string. When the command robot receives this request, it will not send content-based interaction instructions. Instead, it will send the content stored in the body request as instructions to the ID's live trading. We need to make an agreement in advance for the message format in the body. If we don't do this, the robot may receive a message that it doesn't understand, so it won't be able to perform the corresponding operation. Therefore, the prerequisite for doing so is that the robot's operation must be in a predetermined format with our strategy. With our strategy program and the message instructions configured on TradingView. Here we agree that the format of this message delivery consists of the following fields. The first one is flag, which we can write as another ID, or something like that. We can customize the ID, such as naming the Docker, naming the order as long for opening long positions, and short for opening short positions. Then in the field of the second message, we can specify the configured exchange object to be operated on, as we can configure multiple accounts on the FMZ Quant trading platform. The account we want to operate on can be specifically specified in the message. And we can also specify which trading pair this message operates on here. If we want to operate on spot, we can write spot. If we want to operate on futures, we can write specific future contracts, such as swap for perpetual contracts, quarter for quarter contracts, and next quarter for next quarter contracts. Next, we can use some placeholders to represent the current order price. If we want to use the current closing price as the order price, we can use the close placeholder. It should be noted that this format consists of two curly braces with names in between. When this message is actually sent on TradingView, it will replace this part in the content with the current closing price, and then send the message. There's also the format of action buy. And we want this message to include opening long positions, opening short positions, buying, selling, closing long positions, closing short positions, etc. We need to make an agreement here. The last one is the order quantity. We need to make the operation open one contract or two contracts, or buy 0.1 or 0.2, which we can agree on in the amount field. In this way, our strategy is designed as a multi-exchange architecture, which means that it can operate the corresponding account based on the exchange field you pass in. If you pass in 1, we will operate on the first configured exchange account. If 2 is passed in, we will operate on the second configured exchange account, and so on. The following is a strategy included in our solution design. If you are interested, you can take a look at the strategy codes. The complete strategy code, including parameters and interaction settings, has been published here. And we can also click the link to copy the complete strategy. Click Copy and Backtest. And here we click Save. Go back to our strategy list. Refresh the page, and we can see that the strategy was fully copied to our own strategy library here. With the strategy, we also need to run a Docker and configure API keys. We will complete the following preparation work. First, we will deploy a Docker. On the FMZ Docker page, we click Add Docker here. And we choose one-click rental Docker VPS. And we select the Docker for the Japan server. Click Buy it now. Click OK. And input our platform login password. Click Authorization. And we can see the status is installing. Wait for a moment. Here we can see the status is online now. Our Docker has been completed. Secondly, let's add an exchange object. We will use the OKX Futures exchange object for testing. Here we select OKX futures. We will fill in the corresponding API keys that have been applied for on the OKX exchange. It should be noted that the access key, secret key, and passphrase we have applied for on the OKX futures on the OKX exchange need to be properly stored. When configured on FMZ, they are encrypted on the browser, and the FMZ platform does not store any plain text information. After we have configured the exchange object, we can add exchange account to the bot. Here we go to the bot page. We click Add Bot, and we name the bot as Test. Select the strategy we have just copied, as well as the Docker we have distributed. In the strategy, we need to configure the extended API key of the FMZ Quant trading platform. Let's go back to the account page. We copy the access key and the secret key separately. Access key to here, and the secret key. However, it is not necessary for the strategy to actually execute TradingView transactions. The purpose of doing this is to generate a webhook URL link for us to copy and paste easily, because the strategy can read its own robot ID. In addition, when we use the testing function, we also need to use the extended API key of the FMZ Quant Trading Platform website. We have added the extended API key of the FMZ Quant Trading Platform website that we have just created to the strategy. This is only for testing purposes, and it's also possible to not configure it during actual execution. However, the webhook URL of TradingView needs to be filled in by ourselves. It is not convenient to copy and paste directly. After configuring the keys, we can add the previously configured OKX account. Here we choose the platform OKX futures and the trading pair as BTC USD. We click Add button and click Add Robot. And here we can see that our live trading has been created successfully. At the beginning, when the bot didn't receive any signal, we didn't do anything. This is the status we see on the interface now. At this point, we can see that the bot automatically generated the robot's webhook URL here, and we can copy it. We can copy the content directly later. So let's go back to the document. We prepared the TradingView Pro account. We need a testing Pine language script for TradingView. If we want to run a Pine language strategy on TradingView and have it issue transaction instructions, we will use FMZ Quant Trading Platform to have the robot actually place an order. Then we copy the Pine language script to the TradingView. Pass it here. And we click Save. We can see the script name is consecutive up down strategy, click Save, and add to the chart. And we can see that the strategy has been added to the chart. The strategy only triggers the trading signal at the real-time K-line bar. So after we added it, the trading signal triggered on the historical K-line bar will not show. Let's go back to the document. We need to add an alarm to the agreed format. Of course, there are many placeholders in the script, which can obtain the number of orders placed at that time, extension information, and alarm information. And it is also possible for the TradingView scripts to send an indicator line drawn at that time. Next, we will create an alarm message for the TradingView. We can click the alarm logo at here and click Create Alert. Of course, the alert we create can select certain price conditions on this chart, such as how much price goes up, goes down, or decreases. However, we do not let this alert monitor the content on the chart, but let it monitor the strategy. Here we select the strategy consecutive up-down. And we want the alert to monitor this script. So here we need to select the script to be monitored. We set the expiration as unexpired. And in the notification column, we uncheck the notifying app and check show pop-up and webhook URL. And we go to the robot test page. We copy the webhook URL address. After we pasted the webhook URL here, we go to the settings column. We need to agree on the content of the message. We cannot use the default message content. We will use the message example just now. Here, we just copy it and paste it here. Because the chart is the Ethereum market trend, we need to modify the message content, which will pass the ID of the strategy order. That is, the ID in the script will be passed to the flag position. We will let it operate on the first exchange object of the robot, and we change the BTC to ETH, USDT here. And the contract we need to operate on is a perpetual contract, and we use -1 as the price to place an order, using the market price. When we use a script to trigger an action, the content passed in the comment field, such as in the strategy order line of the script. When the script places an order and triggers it, the comment is an action. If the action is close sell, then the strategy order comment will become close sell. If the action is long, then a long will be passed in accordingly. We use this operation to distinguish instructions from open long, open short, close long, and closed short. This is triggered based on the actual situation rather than fixed content. Finally, we need to set the order amount triggered by it using the place order strategy order contracts. For example, if the order amount of the strategy long is 1, then strategy order contracts will pass in 1. After we have written the alert, we can directly click Create. Here we can see the alert has been created successfully. When the alert log appears, the alarm log column, the alerts log column here will be displayed. Just now, our signal was a short signal, and then we enter a close short signal. Now we are in a state of no position. And the next time we trigger the signal, we may proceed with actual trading. In this document, we also record the previous tests actually. After configuring the alert transaction signal on TradingView and triggering the signal in the actual chart, an alarm log pop-up will be triggered, and the corresponding order operation will be carried out by the strategy. Let's go back to TradingView. Here we can see that the strategy triggered the transaction operation here, and the alert log here, it appears the logs in the column. We can see the strategy ID displayed in the alert message is comes offline. And then we can see that the alert operation in the strategy order line is triggered, and the first exchange object that triggers the alert information operation is the perpetual contract of Ethereum. The market price order and the direction is long, which is the long trading direction we previously agreed on for futures. The order amount here is 1. And there is also an alert in the alert column, log column for 1 contract. The corresponding robot has actually performed an actual operation, and we have recorded it in our passage. The corresponding robot has actually placed a long contract operation. On our FMZ platform, you can also use the trading terminal to check if you have any positions. The trading terminal also retrieves information from the API interface. Let's go back to TradingView. The strategy is still running. The closing position trigger has also performed the corresponding closing operation, and we have also recorded it in our passage here. And if we want to close the alarm, if we want to turn it off, the alert, we can click to remove it, and it will no longer push messages to our robot. So the above is a complete demonstration of the solution. If you think our video is helpful for your quantitative trading, don't forget to like, follow, and repost our video. Thank you.